Hey televisions, back with me again, Gautama Putrada. I am your lecturer for operating systems. This is our 8th meeting about memory management. In the 6th video, we will be talking about segmentation. So if you still remember, in the last video we were talking about paging, and now we are moving on. So in partitioning, there is fixed and dynamic partitioning. Fixed partitioning causes internal fragmentation, and the solution is paging. And in dynamic partitioning, it causes external fragmentation, and the solution to external fragmentation is just like the name of this video, segmentation. So repeating the problem of dynamic partitioning from video 2. Here uh, process 1 to 20 megabytes, and process 2 is 14 megabytes, and process 3 is 18 megabytes, and process 2 leaving a fragment of 14 megabytes. And for example, if we have a process that is 16 megabytes, I'll just draw that down. What happens if we have a process that is 16 megabytes? It couldn't fit. And segmentation is just like paging, but in segmentation, the segments are not fixed size. Just as the page are fixed size for a fixed size partition, the segmentation isn't fixed size, just like the dynamic size of partitioning. So if there's only 14 megabytes, we will divide this process into two here. So there are two partitions. The first one is 14 megabytes, and the second partition is 2 megabytes. And this looks like a bit better solution than paging, but you can imagine in paging the page table is somewhat simplistic. And if we have something like dynamic partitioning, we can imagine the dynamic table is more complex, and this we will learn in the next page. So here is a comparison between page table and segment table. The page table is here at the top, and the segment table is here at the bottom. Because each process is divided in paging. Each process is divided in a fixed size of page. Mapping the page number and the memory address is somewhat simplistic. Here we can see page 0 is mapped to the memory address 000101, and now more information is needed. And as we can imagine, in segmentation, each segment has a different size of size. So if we are searching for an address, we have to know the size of the segment. So mapping the segment number to the memory address is not enough. We need to know the precise length of the address. So here we see, for example, in segment number 0, segment number 0 has the base address here. So this is the base address, and from this base address we add the logical address here to the base address, and then we check if it exceeds the length or not. If it doesn't exceed the length, it means that the logical address that we are searching is inside this segment. So if we add this base with this logical address, we will get the physical address, and we can take the address that we want. And we will learn an example of that in the next video. So that is the end of video 6. In video 6, we have successfully discussed about segmentation. In the next video, we will give an example of segment mapping between the logical address and the physical address. Thank you for your attention.